Good morning, my dear students. Today we will going to discuss the last topic in this polymer processing, that is polymer processing techniques. Yeah, see, we have already discussed certain techniques in processing the polymers. So here also another two techniques which are similar to that, but some textbooks they will give in this way, and some textbooks they will give it in a different way. So you can just go through these techniques for this session. So we'll just quickly, I will just rush up these things because some other textbook they have given the concepts in this way. Okay. So let's start with the polymer processing techniques over here. So we have listed seven different techniques here. So extrusion, film molding, sheet thermoforming, blow molding, transfer molding, compression molding, and injection. Okay. Let us look into the each one concept, each technique, how the polymers will be processed. Okay. Let us start with the first one. Sorry. Yeah. The first technique is the extrusion. So I think already we discussed the technique which is similar to the extrusion. So extrusion process basically is continuously shaping a fluid polymer through the orifice of a suitable tool and subsequently solidifying it into a product. So in case of thermoplastics, the feed material in the powder form or a pellet form is most commonly heated to a fluid state and pumped into the die through the screw extruder. It is then solidified by cooling after exiting from the die. Extrusion products are often subdivided into groups that include filaments of circular cross-section, profiles of irregular cross-section, axis symmetric tubes, and pipes, and the flat products such as films and sheets. Here, the concept of obtaining a polymers by using extrusion, it is similar to that of what we discussed in the case of wet spinning technique as well as in the dry spinning technique. Okay. So basically, I think you might have studied the metal forming processes in your last semesters, so where the concept of extrusions might be knowing over there, right? The same similar concept here, the similar process, the forming process over here. So in the case of an extrusion, the fluid polymer is being shaped continuously, and as it passes through the orifice of a suitable die or a suitable tool, and subsequently solidifying it into a product or extrude of a constant cross section. So one important thing what we should remember in the case of an extrusion is the cross section will remain same. Okay, constant cross section you will go to get it, and as you pass the heated the fluid polymer, so through a suitable die. So I will show the sketch in the next slide there. So that heated polymer will get converted depending upon or based upon the tool or the die what you are using. So and after solidification, you will going to get the product in which is having a constant cross section. So in the case of a thermoplastic, the feed material which will be in the form of a powder or a pellet, and it is being heated. See, the thermoplastics are heated to a fluid state, and it is being pumped by means of an external power or external agent, and it is pumped into the die through the screwdriver. So screwdriver will be there, it will go into turn and it will go into push it, and as it passes through the dies, so the dies will be having the similar shape as that it is required for the final product. And after solidifying or after cooling, the die or which comes out of the die, so you will going to get the product which will be in the required shape, and generally it will be having the constant cross section. These extrusion products might be grouped into a filaments of circular cross section. Generally, the products will be made out of made with a circular cross section, profiles of irregular cross section, axis symmetric tubes, and pipes. I think these examples you might have studied in your the concept of extrusion in the lower classes. Okay, so this is a diagram what we are showing here. In this diagram, what it is showing here is the extrusion dies can have a complex shape. See, this is the die. Okay, so the die can have any kind of shapes, so any kind of complex or intricate shapes it can have. So based upon the shape of the die, the final product what we will going to obtain, so it will have the same shape. So here it is, you can see the diagram one, it is showing distribute the material across the width of the sheet. So this is a compensate for the wall die. See, it is a die spell. Okay. And then this part, second sketch, what it is showing here is distribute material across the width of the sheet. See, so this is the die clips here. This is the die over here. Okay. So what you get here is it is a manifold where you will go into pass or we will go into supply the raw material or the polymer, which will be in the form of a fluid. In the sense, in the case of a thermoplastic, it is been heated to its liquid state and it has been pumped through the die by means of a screw. Okay, so now it will pass us through, and then you will have a die, and it is an adjusting script. So what kind of what cross section is supposed to have? So this is the case. So this is the very simple and the basic diagram or the sketch of an extrusion. Okay, and sometimes you might be having the coating on the outer surface of the product. So in such case, you can also have the coat a wire. So just especially in the case of a wire, so wire it requires insulations or sometimes it may require any coating required. So you can have the coating provision also can be obtained in this case. So this is the technique where you can produce the polymers which are having the circular cross section. Okay, this is very important from the examination point of view. A concentric and shapes, only thing you have to explain the sketch. Sketch is very important over here. So draw the diagram and then explain what's happening so you can get a things. Okay. Second important technique over here is film blowing. The film blowing process is basically consists of extruding a tube of molten thermoplastic and continuously inflating it into several times initial diameter to form a thin tubular product that can be used directly or split to form a flat film. This is a different kind of process what we are not discussed till now. In this case, uh, the extrusion of a tube of a molten thermoplastic. So basically, it is the process is a second type of process. What technique? What I am discussing here, it is film blowing. Film blowing basically it consists of an extruding a tube of molten thermoplastic and continuously inflating it into several times its initial diameter. Sometimes, so when you look at this diagram, what we have shown in the slide here, the process looks similar to that of an extrusion process. But only thing is the product or the thermoplastic has been thermoplastic tube. We are making a tube. The thermoplastic tube has been extruded out and it has been continuously inflated with an air to several times its diameter to form a thin tubular product that can be used directly or split to form a flat film. So this is basically this type of process are used for making the film-like structures or just like a tubes which are having a halo structures, right? So the process is similar to that of an extrusion where you are heating the polymer, a thermoplastic to its molten state, and then you are just feeding the molten material into the dies by means of an pumping or by means of an air screws. And then as it passes through the dies, the dies might have the shape what it is required for the final product, and heated polymer as it passes through the dies, and after solidification you will going to get the required product. This is the process of extrusion. But the film blowing, what happens, it is the next step. So where, so after extrusion a tube from of a molten thermoplastic, you are inflating, you are just blowing the air so that its diameter is several times its initial diameter. Okay, and the purpose of inflating is here to form a thin tubular product. Okay, so you need to have very thin shaped tubes. Okay, and then which can be directly used as a tubes, or it can also be used as a flat film. So this is what we call it as the film blowing. So this is similar to that of extrusion. Only the small thing what you can change is here is inflation. The films produced by film blowing process are widely used for agricultural, construction, and industrial applications, including covers for silage, greenhouses, chemical or solar ponds, flat cars, etc., or for variety of packing applications, which includes wrap, can lining, fabricated bags such as garbage bags, gazetted, VTech, W4, fashion bags, and T-shirt bags, tags for big persons. So this is what we are talking about the applications. So the main purpose of this film molding is to get the what we call it as the films. The films what you obtain, it is used basically the main application or main usage of films is for agricultural and construction and industrial applications. So which includes covers for silage, greenhouses. You might have seen in the fields they might have used these films also. They might have for covering purposes, and okay, and also for various variety of packing applications also is there, including wrap, can lining, fabricated bags such as for garbage bags, deserted VTUX or W folds. So like that, there are so many applications you can find by just obtaining the films or film-like structures from using this blow molding technique. Okay, and also you can see it has also used for fashion bags and T-shirt bags, bags for groceries, T-shirt bags for groceries. So like that, you can just when you just look at the different applications, so you will have a variety of applications where you will be having you are using those things in your daily life. Okay, so please remember the film molding is also as similar to the extrusion. Only thing what you should remember here is after the product has been extruded, it needs to be inflated to increase its diameter several times its initial diameter. This is regarding the film mold. The third technique here is sheet thermoform. Sheet thermoforming or simply thermoforming. I think I discussed the concept of thermoforming in the last class. And of course, sometimes they have given this process under this techniques also, because in the syllabus they specified polymer processing techniques. So I'm just taking again once again this one, sheet forming or sheet thermoforming or simply thermoforming. So which involves the heating of a flat thermoplastic sheet to a softened state above the glass transition temperature of non-crystallizing thermoplastics or near melting temperature or crystallizing. And once you heat the thermoplastic sheet to a softened state, followed by deforming of a softened sheet into a desired shape by pneumatic or mechanical means, and finally its solidification into the shape by. It is similar to that what we discussed in the last class, thermoforming by means of vacuum forming or pressure forming or mechanical means. So this is a forming, so where the sheet is thermoplastic, the flat, heating the thermoplastic sheet to a softened state. Softened state here is, so it depends upon the structure, whether it is a crystalline structure or it is having a non-crystalline structure. So if the thermoplastic is having a non-crystalline structure, so you have to heat or such kind of materials will get softened at their glass transition temperature. We generally note it as a piece of heat. And if it is a transition once, then you have to heat it near. Means in the sense such kind of thermoplastics is often near to the melting temperature. It is denoted as T suffix n. So depending upon what type of whether it is a crystalline thermoplastic or it is a non-crystalline thermoplastic, so you can heat such thermoplastic to its temperature so that sheet will get softened. And once it gets softened, then you need to deform it. So deforming in the sense, once the material gets softened, it is very easy to give a shape by means of a deformation or deforming it, what we generally call it as forming. Okay, and followed by the deformation or forming of the softened sheet into a desired shape. So you can import whatever the shape you want by means of a deformation or deforming it or forming it by pneumatic or mechanical. So deformation can be done either by means of pneumatic, either air or pressure or vacuum pressure, or by means of a mechanical also. And finally, its solidification into this shape by. So once the hot sheet metal gets deformed by means of whether it is a pneumatic or mechanical means, and it after that it will get allowed to get solidified. And solidification will be solidification or nothing but the cooling here. So once it gets cooled, so you will going to get the required shape of the product, final product. So this is what the sheet thermoforming has already been discussed in the previous class. So look at this diagram over here. So there are four sketches, line sketches being shown here, 1, 2, 3, 4 here. So sketch number 1, a flat plastic sheet is softened by heating. So you can use electric gradient heater. So by using electric gradient heater, so you will go into soft thermoplastic to its near to its melting temperature. No, it's not get melted, near to its melting temperature. So based upon what type of structure it is having. Okay. So once it is been heated, so then it is being kept over the mold. See, this is what we are showing here. So the mold is here. Okay. So once it is this is the mold cavity. This is what the shape of the component what is being required over here. And here we are heating the thermoplastic sheet to its molten state by means of radiant heater, and then we will going to keep this softened sheet over this mold. Okay, so then it will be clamped together. Okay, then so this is what we call it as the first sketch, where the thermoplastic sheet is heated to its near to its molten state. Then coming to the second process, second step over here, or the second sketch here, the softened sheet is placed over the concave mold cap. Look at here, see, it has been placed. The hot or softened sheet metal is the thermoplastic has been placed over the mold cavity, and this is the diagram what we are showing here. Okay, and in the third step here, a vacuum draws sheet into the cavity. See, here you can observe the vacuum holes over here. Okay, so here once you keep a hot or a softened sheet metal, so once you create a vacuum inside the mold cavity, so this sheet has been drawn. It has been drawn, or it has been deformed, or it has been formed by means of a vacuum. So vacuum drawn, what we can see in the third sketch here. The vacuum draws the sheet into the cavity. See, because of the vacuum, so the vacuum will go into draw the sheet so that that sheet can take the form of a mold cavity. Okay, so you can see how the forming or deformation is being taking place over here. And the last step here is the plastic harden as contact with the cold mold surface, and pot is removed and subsequently trimmed from the. Once it is been that the hot sheet metal has been vacuum drawn into the mold cavity, and it has been allowed to solidify by means of cooling for a time, for some time. So once that plastic comes in contact with the cold mold, it gets harder. It gets hardened, and after some time, so you can take out that hardened part, and you can remove the clamps, and you can release the part from the mold clamps, and you can trim it off. So if it is anything is not required, so if you find anything is unwanted material or unwanted part, you can trim it off from the. So this is what we call it as the thermoforming. Okay. So where the deformation by means of a vacuum, and also you can get the deformation by means of a pressure, was in what we discussed in the last class, and also by means of a mechanical means by just having uh, the force from the two modes, one positive one, another one is a negative. This is what we call it as thermoform. Okay. The products made by sheet thermoforming include skin and blister packs, individual containers for jelly or cream, vials, cups, cups, trays, and lids. As many as millions of parts per day can be produced with a tool featuring several hundred activities. Larger products are generally made from cut sheets at such shower rates. The heating stage often is a limiting factor. Transparent products such as contour windows, skylights, and cockpits canopies are often made by this method. So some of the applications of the sheet thermoforming. Okay, so you can see there have been plenty of applications from this by making a jelly or a cream or a vials or a cups or a cups, and you can see some more transparent products such as contour windows, skylights, and cockpit canopies. So there are plenty of applications are there for this kind of process. There is a thermoplastic process. This means the polymer processing technique. Okay? And next comes the fourth technique, which we call it as a blow molding. The basic principle of the blow molding process is to inflate a softened thermoplastic halo preform against a cooled surface of a closed mold where the material solidifies into the. So it is just like similar to that of what we discussed, the film molding, film blowing. Okay. So in this blow molding process, the softened thermoplastic halo preform against the cool surface of the closed mold. You can see here the diagrams what we are showing here is injection molding of a parison, and second one is a stretching, and third one is a. Okay. So the process is very simple over here. So you will be having the thermoplastic either in the form of a pellets or as powder, and it has been heated to a certain, it has been softened. Softened in the sense, once it is been heated to its nearing melting temperature, it will get softened, and then you are forcing this softened raw material, the thermoplastic, into the die where you will going to get. So you can see the injection mold here. So injection molds you can see here. Okay, so this is called the injection molds. Okay, so by means of a piston, it will go into force or will go into pressurize that raw material, the softened raw material, and it passes through, and it will go into occupy the space of the injection. Okay, so this is what we call it as the initial process, the first process, injection molding of Paris. Okay, then in the second process, what we say here is you can see the piston is here, and this piston in the second process you are stretching it. Stretching it in the sense you are applying this piston, it will go into pass through this and it will go into stretch. It will stretch to a required length. to a required length. This is very important. Once you take it out from the injection mode, right, and then you will go into press this, what we call it as a piston. It is what we call it as a blowing rod. We call it as a blowing rod in blow molding. So it will go into stretch to a required length. That is the one important. Means two important things you should understand here is you can increase the length and also you can increase the diameter of the product. So here, by just making this piston to move and within this, what we call it as the product, so where it will going to be stretched to a requirement, and afterwards the air will be blown through it. So as the air blows through it, it will go into inflate the thermoplastic, hollow thermoplastic. Okay, and this will get again. So you will going to keep it over in the injection mode. Okay, and then you will go into inflate so that you will going to blow the air. Once blow the air, the diameter increases and it will get stick to the walls of the closed mode. Okay, where the material will get solidified into a hollow. This is what we generally call it as the blow molding. Okay, so it looks similar. Similar simple thing here is the blow rods. Blow rods is can also stretch and it can increase the diameter or it can inflate it. So both things will be done by the blow rods. So when you come to the examples here, the packing is the major area of application of small to medium sized disposable blow molded products. Liquid foodstuffs are increasingly packaged in narrow neck plastic PET patterns. Blow molded containers are also used for cosmetics, toiletries, pharmaceutical and medical packaging and variety of household. These are some of the applications what you can see from the blow molding technique. So where you can have an applications from small to medium sized disposable blow molded products. Liquid foodstuffs are increasingly packaged in narrow neck plastic PET bottles. I think you can see the bottles, so whether it is 100 ml or 200 ml bottles, not even liters, half liters or 1 liter bottles, just like a drink water or any soft drinks. So these are also, when you look at the bottles, how the bottles have been made, the bottles have been made by this means of this blow molding. So you will take the water bottles, so it will have a different diameters depending upon the capacity of the liquid that needs to be stored. It will have a different diameters. So these kind of bottles, whether a water bottle or soft drink bottles, so they will going to be formed by means of this blow molding. Neck plastic PET bottles, you can see. Blow molded containers are also used for cosmetics, toiletries, pharmaceutical, and medical packaging and a variety of household. So these are some of the applications of or some of the products which you can manufacture by means of blow molding technique. Let us move on to the fifth one, which we call it as a compression molding. The compression molding process, the fifth technique in this polymer processing technique, is used for temperature activated thermosetting polymers. Compression molding basically involves the pressing of a deformable material charge between the two halves of a heated mold and its transformation into a solid product under the effect of elevated mold temperature. Compression molding temperature are often in the range of 140 to 200 degrees centigrade. Mold pressures can vary from 35 atmosphere pressure to 700 atmosphere. Material charges are often preheated to speed up the initial softening stage. Compression molding is characterized by slow and moderate flow of the very viscous material charge within the cavity, and it is not normally suitable for making complicated parts or parts featuring fragile pieces. See, this type of technique is very much used for a temperature activated thermosetting polymers. And in this process, you are pressing a deformable material charge between the two halves of the heated. Here, the mold is heated, okay, and you are pressing the deformable material between the two halves of the mold, and its transformation into a solid product under the effect of elevated mold temperature. In the sense, it gets converted into the shape of the mold when you heat the mold towards highest temperature. So the most of the times the temperature will be in the range of 140 to 200 degrees centigrade, and also the pressure what you are maintaining, it is 35 atmosphere to 70 atmosphere. Okay. So basically, this compression molding is characterized by the slow and moderate flow of very viscous material charge into the cavity. And most important thing here is it is not normally suitable for making complicated parts or parts featuring fragile. This is the diagram what we are having for compression mold. The charge is loaded. So this is a charge. The first diagram what we are showing here, it is the charge. So this is the upper mold and this is the lower mold. So both the molds will get heated up, will be heated, and then it is a punch. It is just like a punch and it is a cavity. Okay. So the charge is placed in the cavity over in the lower mold half. Okay. And when you move to the second step here, so this upper mold pass, it will just move towards and it will go into this compress it. And once it compresses, so that the charge will get to the shape, it will go to fill the shape of the mold. So you can see this molding shape how you are getting here. Okay, and gets cured. And then the step number 3. So where we are getting the step number 4. Sorry. Step number 4. So here your charge is compressed and it has been cured. Okay, is that for some time. And then the next step, what you can see, so the upper mold moves up and you can remove the finished product by just the plunger. The plunger will go into pushes this finished product out of the lower mold half. So this is how we generally get this product by using the compression. Okay. Next comes the transfer molding. The transfer molding is often associated with compression molding because it is used with the same two classes of material, temperature activated thermosets and vulcanizable rubber. In transfer molding, a softened temperature activated material is transferred to a narrow gate into the closed cavity of the heated mold where it too stays solid. So transfer molding is normally used with materials that have fairly high pre-curing fluidity, facilitating the flow from load area to the cavities. This also permits the molding of complex parts and featuring fragile. The transfer molding and the compression molding both are similar, or they are associated with the same concept here. And because it is used with both the two classes of materials, temperature activated thermosets and vulcanizable rubber. So only small change what you can observe in transfer molding is the softened temperature activated material is transferred through narrow gate into the closed cavity of the heat. So in the compression mold, the cavity was open. So here it was closed cavity, and of course mold is heated. So there will be a small gate through which you are going to transfer the heated temperature activated material, and then it will get solidified into the solid, into its required shape. This is compression molding and transfer molding will remain same. Only the small change what you can say here is the softened temperature activated material is being transferred through a narrow gate into the closed stack. This is the only small difference you can make it out with the transfer. And the last technique what we discuss is here is injection molding. The seventh technique. Injection molding process involves the rapid pressure filling of a specific mold cavity with a fluid material, followed by the solidification of material into a product. The process is used for thermoplastic, thermostatic resins, and rubbers. So, what does this injection molding involve? Is it is rapid pressure filling of a specific mold cavity with a fluid material, followed by the solidification of the material into a product. In the sense, you are just you are pressurizing the material to fill the mold cavity by means of a piston or whatever it may be, and then you are allowing the hot metal to get solidified into the product. So this type of process is used for thermoplastics, thermosettings, resins, and others. So this is the diagram. What you can see here is this is the front view and this is the top view of the product process here. Okay, so here we have an hopper through which we will go into pour the material. So we have a piston or a ram. Okay, so we have a mold here. This is called a heating zone. Okay, so this is a cooling zone, cylinder, barrel, injection chamber. So once the powder pellets has been loaded, the piston will passes, it pressurizes and it will passes the raw material into this heating zone. The material gets heated up and this is the mold. This is the mold cavity what we are having here. So once it passes through, so heated metal, it will going to get the shape. Look at this shape of the product over here. And you are allowing this heated, the pressurized product to get solidified by means of cooling for some time. Okay. And then, so look at here. And then you will go into these two are called ejectors. These two pinpoints, what we call it as ejectors, this will going to be taken out, and these are all called press. You're going to press it here, the mold part, and then finally you will going to remove. See the part A, projector plunger, and part B, it is a reciprocating rotating. So it will going to rotate it, and see this is the one piston. So just like a piston, it is here, and second one, what we are showing here, it is a reciprocating rotating screw. So there are two different things which you can get the pressure or fill the material into the mold. Okay. Injection molding of thermoplastic can be divided into several stages. At the plasticity stage, the feed unit operates pretty much as an extruder, melting and homogenizing the material in this valve. This screw, however, is allowed to retract to make room for the molten material reservoir. At the injection stage, the screw is used as a rod for the rapid transfer to the molten state. Okay. Since the mold is kept at a temperature below the solidification temperature of the material, it is essential to inject the molten material rapidly, ensure complete filling of the activity. High molding packing pressure is normally exerted to partially compensate for the thermal contraction of the material upon cooling. After cooling stage, the mold can be opened and the solid product is ready. Okay. So this is regarding the injection molding. So we have some more problems encountered in injection molding. I think my time is getting down. Okay. So some of the just quickly I just did it. Jetting, air trap, short, sink mark, and weld line. These things are going to put it in the Google Classroom, so you can just refer these things. And afternoon we will have a class. Okay, so we will discuss these things in the afternoon. Okay, so we will discuss polymer powder metallurgy in the afternoon class. Okay, so this is the completion of a processing of polymers. So the second part of the module 3 is a powder metallurgy. I will going to discuss in the afternoon.